This is SpaceTime Series 26, Episode 28. Coming up on SpaceTime. New studies suggest the Earth's magma ocean solidified faster than thought. A potential new approach to the search for dark matter. And two key NASA space missions suddenly go offline. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims the Earth's original magma ocean must have solidified in just a few million years, rather than the hundreds of million years previously thought. Planet Earth was created some 4.6 billion years ago as tiny particles condensed out of the gas of the early solar system's protoplanetary nebula. Gradually, these particles coalesced and eventually grew into small protoplanetary blobs. And they eventually collided with each other under their own gravity and continued to grow and accrete more mass as they were bombarded by countless asteroids and comets. The heat generated by all these ancient impacts kept the planet molten in a state scientists refer to as a magma ocean. Then about 4.5 billion years ago, a body about a third the size of the Earth, roughly the same size as the planet Mars today, a body which scientists now call Theia, slammed into the proto-Earth, keeping the planet molten, with some of the ejecta thrown into orbit, eventually coalescing to form the Moon. Meanwhile, the asteroid and comet bombardment would continue for more than another 500 million years. But gradually the magma ocean began cooling and solidifying. As the magma ocean cooled, heavier elements such as iron and nickel migrated towards the center, while lighter elements floated on the surface. Eventually, planet Earth as we know it today was formed, with a solid iron-nickel inner core, surrounded by a molten liquid metallic outer core, a thick mantle, and a thin crust. But exactly how long did it take the magma ocean to solidify? It's an important question because the rate at which the magma ocean cooled would have affected the formation of the distinct layers within the Earth and the chemical makeup of those layers. Previous estimates suggest that it would have taken hundreds of millions of years. But a new study reported in the journal Nature Communications narrows those large uncertainties down to less than just a couple of million years. The study's lead author, Magma from Florida State University, says the magma ocean was an important part of Earth's history, and this study helps answer some fundamental questions about the planet. You see, when magma cools, it forms crystals. And where these crystals end up depends on how viscous the magma is and the relative density of the crystals themselves. Crystals that are denser are more likely to sink and thus change the composition of the remaining magma. The rate at which magma solidifies depends on how viscous it is. Less viscous magma will lead to faster cooling, whereas a magma ocean with thicker consistency will take a lot longer to cool. Just like this current study, previous research has always used fundamental principles of physics and chemistry to simulate the high pressures and temperatures in the Earth's deep interior. Scientists also use experiments to simulate these extreme conditions. But the problem is the experiments are limited to lower pressures, the sort which exist at shallower depths within the Earth, not at the planet's very center. So they can't fully capture the scenario that existed in the planet's early history, where the magma ocean extended down to depths where pressures and temperatures are likely to be 3 times higher than anything that experiments can reproduce today. To overcome these limitations, Mercury and colleagues ran their simulations for up to 6 months, and this helped eliminate some of the statistical uncertainty of previous studies. The research also helps explain the chemical diversity found within the Earth's lower mantle. See, samples of lava from mid-ocean ridges on the seafloor, as well as volcanic island hotspots like Hawaii and Iceland, crystallize into basaltic rock with similar appearances but with very distinct chemical compositions. And that's a situation which has long perplexed Earth scientists. And it raises the question, why do they have distinct chemistry or chemical signals? Since the magma originates from under the Earth's surface, it means the origins of the magma there has chemical diversity. So, how did that chemical diversity begin in the first place? And how has it survived over geological time? The starting point of chemical diversity in the mantle can be successfully explained by a magma ocean in the Earth's early history, one with low viscosity. And a less viscous magma led to the rapid separation of the crystal suspended within it, a process often referred to as fractional crystallization. So, that would have created a mix of different chemistry within the magma other than a uniform composition. And the low viscosity means the magma ocean also solidified faster. This is SpaceTime. Still to come, a newer approach in the search for dark matter, and 2 key NASA missions suddenly go offline. All that and more still to come on SpaceTime. Scientists are studying an unusual form of the cesium atom which could help in the search for a particle to explain dark matter. The unusual atom, reported in the journal Physical Review Letters, is composed of an ordinary cesium atom and an elementary particle called a muon, which is basically a heavier version of an electron with about 200 times the electron's mass, and in this particular configuration it orbits about 200 times closer to the nucleus than a normal electron would. The authors say the particles may prove essential in a better understanding of the universe's fundamental building blocks. The study's lead author, Dr. Jacinda Gingas from the University of Queensland, says much of the universe remains a mystery to science. Astrophysical and cosmological observations show that regular matter, the stuff which makes up the stars, planets, clouds, trees, houses, cars, dogs, cats and people, makes up only around 5% of the total matter and energy content of the universe. The rest, the overwhelming majority, is dark. Not because it's black, but because scientists have no idea what dark energy or dark matter are. Scientists simply know dark energy exists because they can see the expansion rate of the universe out from the Big Bang 13.82 billion years ago is accelerating, rather than becoming steady or slowing down or even reversing under the effects of gravity. And they know dark matter exists because they can see its added mass preventing galaxies from flying apart as they revolve, and also because it provides gravitational lensing for distant background objects. But despite being able to see its effects, dark matter remains mysterious and invisible. The leading candidates for dark matter are weakly interacting massive particles, or WIMPs, yet to be discovered subatomic particles like the hypothetical axion or sterile neutrino. Gingas says the search for dark matter particles lies at the forefront of particle physics research, and this work with cesium may prove essential in solving that mystery. The work may also one day improve technology. Atomic particles play a major role in technologies people use every day, such as navigation with things like the Global Positioning System, and atomic theory will continue to be important in the advancement of new quantum technologies based on atoms. Through theoretical research, Gingas and colleagues have improved science's understanding of the magnetic structure of cesium's nucleus, its effects in atomic cesium, and the effects of the weird muon. Because muons are 200 times more massive than electrons, and because they orbit the nucleus 200 times closer, they can better pick up on details of the structure of the nucleus. And this will help improve atomic theory calculations used in the search for new atomic particles, just like the hypothetical axion or sterile neutrino. The authors say the new approach can offer greater sensitivity and provide an alternative technique to finding new particles through the use of precision atomic measurements. It's the sort of research which is currently done by particle accelerators like the Large Hadron Collider at CERN. The Large Hadron Collider, or LHC, smashes packets of subatomic particles together at close to the speed of light, in the process recreating the sorts of pressures and temperatures that would have occurred in the moments after the Big Bang. In these cataclysmic collisions, new ephemeral particles sometimes emerge. Gingas says her team's research can offer greater sensitivity using an alternative technique to find new particles through precision atomic measurements. She says it doesn't need to be a giant collider and instead uses precision instruments to look at atomic changes at low energy. Rather than explosive high-energy collisions, it's the equivalent of creating an ultra-sensitive microscope to witness the true nature of atoms. So this can be a more sensitive technique, unveiling particles that atom smashers simply can't see.
So in the hunt for dark matter and other possible particles, yeah, that is correct. And The reason that cesium is so important to us is because it's almost like, I guess you could say in some sense, like a heavy hydrogen atom in terms of modelling it, because it has one valency electron above tightly filled electron core, which means that when you're doing atomic experiments and atomic calculations with it, you can understand it fairly well. So it's one of the very heavy atoms, and some of the very most precise experiments are done with cesium. So it's also worth pointing out that one of the experiments for cesium for one of the energy splittings defines the unit for time, the second, the SI unit for time. So this is defined by one of those energy splittings. So it can be understood really well experimentally and also in terms of the theory. And when you're doing these sorts of experiments to try to look for new possible particles beyond the standard model, you need to do certain types of experiments incredibly precisely, and they need the atomic theory to be done at that same level of precision in order to deduce information about possible new particles that could be being produced and then annihilated and contributing to certain amplitudes in the cesium atom.
You've then introduced this additional particle, the muon. I've always referred to it as a heavy electron. Normally in nature, this is very ephemeral. It doesn't hang around for very long. How are you using it?
So I'm a theorist, so I'm not the one that has to do the experiments with it, fortunately. But there is experimental data that we found and seem to have been forgotten in our community for some years. Experiments from the 1960s where they did very precise measurements of hyperfine splitting. So it's like the splitting in the normal cesium atom, but in this muonic cesium. And then they were able to deduce or to see the effects of nuclear structure in this energy splitting in this muonic cesium. So in terms of, indeed, it doesn't last for very long. So this is a very short-lived elementary particle, the muon, and they managed to inject it into the cesium atom, and it ends up orbiting, it orbits the nucleus at a very small distance, much closer to the usual electrons.
Technical issue here. When you refer to it as a cesium atom with a muon in it, is it still an atom? Or, I mean, normally when you talk about isotopes, you're talking about additional neutrons. Is there another name for an atom with an additional electron?
Well, an additional elementary particle is often just referred to as a type of exotic atom, so, muonic cesium.
Yeah, I like muonic cesium. I haven't heard that before. I think that's great. I think I'll use that. The hunt for a particle that fills the need of dark matter, it's going to be a heavy particle. Right now, they're looking at things like axions and sterile neutrinos. Is that the sort of way this will go?
So there's a couple of things that I should point out. First of all, our interest in muonic cesium is in order to understand better the nuclear structure of the cesium atom. Because this muon is lying pretty much on the nucleus, it's picking up on all of those details. And what we've managed to find is some of the best information on the magnetic structure of the cesium nucleus. So it's got to do with the current inside the nucleus and so on. So, the nucleus has basically like a magnet, and this interacts with the magnetic field of electrons, and for muonic cesium, the magnetic field of that muon, and causes an energy splitting. And so for this reason, we've managed to deduce for the first time detailed information about the effects of the nuclear structure for cesium in the muonic system. Then we translated that to what these effects would be like in atomic cesium. And it's through that we're able to reduce the nuclear structure uncertainties that factor in these precision atomic searches for new physics. So it's sort of indirect. This muonic cesium tells us really about nuclear structure, which enables us to then control our atomic theory, which then enables us to reduce our uncertainty in the searches for new physics. And it's the uncertainty that is the limiting factor when you want to go and detect something new. So when you have the high energy experiments, you want to go to higher and higher energies in order to produce new particles. But this is a very different method where rather than going to higher and higher energies, you go to higher and higher precision. And it's because rather than producing direct new particles, what you do in these precision experiments is you're effectively seeing what's called virtual particles. So they come in and out of existence in a very short time, but they leave behind a signature in certain types of things that can be measured in atoms. And so we're searching for those signatures. And from that, we can deduce what possible new particles are potentially being created and annihilated and showing up in these experiments. So that's sort of a bit of a long-winded explanation, but through this we can actually reduce our uncertainty, which means we can reduce the uncertainty overall of these measurements, which means that we're now able to probe higher energies in looking for new particles. So we can now probe masses of possible new particles that are at higher mass. And in fact, we can probe masses that are higher than what's directly accessible at the Large Hadron Collider, which is limited to 13 tera-electron volts. But as well as that, in these sorts of experiments, we're also sensitive to certain types of new physics, for example, dark matter bosons. So that's a particle that's mediating a new force between particles, potentially. We're sensitive to those sorts of particles that have quite low masses, which would be invisible in experiments at high energies.
So by having this greater precision, you end up with hopefully a higher sigma rating for whatever you find.
Yes, hopefully. So there's an old experiment that was done some number of years ago by the group of Nobel laureate Carl Wyman, but now there are a number of experiments that are aiming to do very much better in terms of their precision. And so we're needing to try to match that precision as well. And we're really hoping indeed to see evidence of new physics.
That's Dr. Jacinda Genghis from the University of Queensland. And this is SpaceTime. Still to come, 2 key NASA missions suddenly go offline. And later in the science report, the FBI finds COVID-19 did most likely leak out of a Chinese government laboratory in Wuhan and then go on to infect the world. All that and more still to come on SpaceTime. NASA has major problems with 2 of its key spacecraft missions at the moment, Maven and Ibex. The Mars-orbiting Maven spacecraft suddenly entered safe mode after encountering a problem with its inertial measurement unit, which measures the spacecraft's rate of rotation. And Ibex, which is studying the interaction between plasma from the solar wind and the interstellar medium at the boundary region of the solar system, has been unresponsive to commands ever since resetting its flight computer. Separate teams of engineers and scientists are now troubleshooting each spacecraft. Maven's inertial measurement unit had been powered up in preparation for a minor maneuver targeted to reduce the orbital ellipse duration in 2027. The spacecraft is currently operating in all-stellar mode, which doesn't rely on this unit. The Mars Atmosphere and Volatile Evolution, or Maven spacecraft, was launched back in November 2013 and entered Mars orbit in September 2014. Its mission goal is to explore the Martian upper atmosphere, ionosphere, and interactions with the Sun and the solar wind, the constant stream of charged particles flowing out of the Sun, in order to explore the loss of the Martian atmosphere into space. Mars has just 1/99th the atmospheric density of the Earth. Maven carries 3 instruments: a particles and fields package, which measures solar wind and ionospheric particles, a remote sensing package, which images the upper atmosphere, and a neutral gas and ion mass spectrometer, which measures the composition and isotopes of neutral gases and ions. The spacecraft has discovered that solar wind and radiation are responsible for stripping away the Martian atmosphere, and that's turned the planet from a warm, wet world capable of supporting life into the cold, freeze-dried desert it's become today. Understanding Martian atmospheric loss gives scientists an insight into the history of the red planet's atmosphere and climate, its liquid water, and its planetary habitability. Meanwhile, NASA's Interstellar Boundary Explorer, or Ibex spacecraft, is failing to respond to commands following a sudden computer glitch. The spacecraft was launched in 2008 to examine the outer edge of the heliosphere. That's the bubble that represents the boundary between the Sun's environment and interstellar space. Mission managers have been unsuccessful in regaining control despite resetting systems on the ground. NASA says the flight software is still running and the spacecraft systems appear to be functional, but commands are simply not processing aboard the ship. Ibex's 15-year mission has included building up the first ever map of the heliosphere, and it updates that map every 6 months. It also discovered a dense region of particles, now known as the Ibex ribbon, created as neutral hydrogen atoms carried in the solar wind interact with the galactic magnetic field. This interaction creates vibrations or waves in the field, and the ions are constrained in ribbon-like shapes. By studying phenomena like this, scientists learn more about the heliosphere. Needless to say, we'll keep you updated on progress in both missions. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. The United States Department of Energy has found that the COVID-19 pandemic most likely arose from a laboratory leak at China's Wuhan Institute of Virology. The institute is the only biological hazard level 4 containment facility of its kind in China, and it was undertaking gain-of-function research on a range of bat viruses, including the SARS virus on which COVID-19 is based. Gain-of-function research is illegal in the United States under potential pandemic pathogen care and oversight framework. That's because of all the dangers involved if it leaks out. So the research was instead carried out through proxies, using a non-governmental organisation called the EcoHealth Alliance, which was then funded and reported to America's National Institute of Health, of which the White House's chief medical advisor, Dr. Anthony Fauci, is the director. It's been alleged the program was set up so the American involvement provided a window for the CIA to observe the operations and methods of China's People's Liberation Army's biological weapons program. A report by the House Committee on Oversight and Accountability states that on February the 4th, 2020, after speaking with Anthony Fauci, the 4 authors of the original March 17, 2020 scientific article, The Proximal Origin of SARS-CoV-2, wrote their study, which was then secretly sent back to Fauci for editing and approval. And it was that paper, which we reported on in the Science Report on March the 25th, 2020, which claimed the virus was more likely a product of natural evolution rather than genetic engineering. In May 2021, Fauci testified under oath before the Senate Judiciary Committee, rejecting claims that his department funded gain-of-function research at the Wuhan Institute of Virology. However, 7 other scientists, who either were virologists or work in associated fields, all stated that the work did appear to meet the National Institute of Health's criteria for gain-of-function research. Alright, so what is gain-of-function research? Well, it involves artificially modifying the genetic makeup of an organism to give it new properties. In the process, replicating what natural evolution might take years, decades, or even centuries to achieve through natural mutations and selections. Basically, it gives scientists a heads up to what a virus could evolve into so that vaccines and other prevention measures can be prepared. But it can also provide a malevolent government with a new weapon in biological warfare. Now, in the case of COVID-19, the research involved the use of 3 chimeric artificial laboratory-generated SARS viruses. These viruses were modified so they could replicate efficiently in human cells using the angiotensin-converting enzyme 2. That's the ACE2 protein that provides the entry point for the coronavirus in order to hook up and infect human tissue. The experiment used humanized mice given the ACE2 receptor that mimicked the human form. In an April 13, 2018 National Institute of Health report, EcoHealth stated that the viral load in the lung tissue of the mice with the chimeric viruses had multiplied over 10 to the power of 6 times per gram of tissue, and that's a strong indication of its potential infectivity in humans. Importantly, no confirmed direct animal-to-human source for COVID-19 has ever been identified, and some of the specific spike proteins needed for human transmission are simply not found in nature. The new findings, first reported in the Wall Street Journal, are based on an updated classified national intelligence report provided to the White House and key members of Congress. Importantly, the findings are also in line with an earlier FBI study, which had actually taken place and reported a year ago but had been kept secret. That study also concluded that the virus likely spread following a mishap at the Wuhan Institute of Virology. US officials declined to give details on the fresh intelligence and analysis that led to the latest findings, saying that while the Energy Department and the FBI each claim an unintended lab leak, they've each arrived at their conclusions through separate methods and for different reasons. Now, a lot of people have asked, what's the Department of Energy got to do with any of this after all? Shouldn't it be worrying about power bills? Well, the US Department of Energy is the American agency responsible for enhancing national security through the military application of nuclear science. In other words, it has control of America's nuclear weapons stockpile before they're given to the military for deployment. And so because of this, it maintains special expertise in the use of weapons of mass destruction. Now, last year, America's Director of National Intelligence said that the SARS-CoV-2 virus, which causes COVID-19, most likely originated in experiments at China's Wuhan Institute of Virology sometime before September 2019. That's when people working at the Institute of Virology suddenly started to come down with strange flu-like symptoms. The head of the FBI, Director Christopher Wray, put it simply. He said it was a lab leak at the Wuhan Institute of Virology.
The FBI has for quite some time now assessed that the origins of the pandemic are most likely a potential lab incident in Wuhan. Let me step back for a second. The FBI has folks, agents, professionals, analysts, virologists, microbiologists, etc., who focus specifically on the dangers of biological threats, which include things like novel viruses like COVID, and the concerns that in the wrong hands, some bad guys, a hostile nation state, a terrorist, a criminal, the threats that those could pose. So here you're talking about a potential leak from a Chinese government-controlled lab that killed millions of Americans, and that's precisely what that capability was designed for.
The FBI says China has repeatedly blocked or interfered with attempts to conduct independent investigations into the source of the outbreak. Instead, Beijing insisted it emerged from outside China, possibly brought in deliberately by American troops. The FBI found that Beijing destroyed evidence, erased files, cleaned up laboratories following the leak, and then disappeared scientists involved in the research.
There are not a whole lot of details I can share that aren't classified. I will just make the observation that the Chinese government, seems to me, has been doing its best to try to thwart and obfuscate the work here, the work that we're doing, the work that our U.S. government and close foreign partners are doing, and that's unfortunate for everybody.
Over 6.8 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization estimates the true death toll is likely to be around 16 million, with some 680 million confirmed cases globally. On an editorial note, public need to learn an important lesson. Just because the ABC, CNN, the BBC, MSNBC, the Washington Post, the New York Times, Facebook, Twitter, Google, or any other media organization says it's fake news or a silly conspiracy theory, doesn't make it so. You really need to search out the facts for yourself. And remember, these are the same media organizations that lied to you about the Russian Trump collusion hoax. They were also found to have lied to you about the Hunter Biden laptop, about the Jussie Smollett assault claim, about the Covington schoolboys, about the Kavanaugh rape allegations, about George Pell, about Andrew Lemming, about Linda Reynolds, and now they've been found to have lied to you about the origins of COVID-19. And have you noticed how quiet the media gets when there are revelations about these issues? You really need to ask yourself why. And let's let comedian Jon Stewart have the last word.
What do you mean by that? Do you mean like perhaps there's a chance that this was created in a lab, there's an investigation?
A chance?
Well, but
oh my
if there was
God.
evidence, I'd love to hear it.
There's a novel respiratory coronavirus overtaking Wuhan, China. What do we do? Oh, you know who we could ask? The Wuhan Novel Respiratory Coronavirus Lab. The disease is the same name as the lab. That's just a little too weird, don't you think? And then they ask the scientists, they're like, how did this... So wait a minute, you work at the Wuhan Respiratory Coronavirus Lab. How did this happen? And they're like, a pangolin kissed a turtle. And you're like, no, the name of your lab. If you look at the name, let me see your business card. Show me your business card. Oh, I work at the Coronavirus Lab in Wuhan. Oh, because there's a coronavirus loose in Wuhan. How did that happen? Maybe a bat flew into the cloaca of a turkey and then it sneezed into my chili and now we all have coronavirus. Like, come on.
Wait a second.
What about this? What about this? Listen to this.
Wait a second.
All right.
John.
Oh, my God. Oh, my God. There's been an outbreak of chocolatey goodness near Hershey, Pennsylvania. What do you think happened? Like, oh, I don't know. Maybe a steam shovel mated with a cocoa bean. Or it's the chocolate factory. Maybe that's it.
That could be.
And now continuing with the rest of the science report. Remember that radioactive pellet that quite literally fell off the back of a truck in outback Western Australia in mid-January? Well, they've finally found it, still lying on the side of the road. The Cesium-137 capsule, which radiates both high-energy electrons known as beta rays and very high-energy photons known as gamma rays, was being transported from a Rio Tinto mine in the Pilbara region down to a company depot some 1,400 kilometres south near Perth. These 8x6mm Cesium-137 pellets are used in radiation gauges in mining to measure flow rates in pipes and the density of certain materials. Cesium-137 has a half-life of about 30 years, meaning that lost capsule would have remained radioactive for over 300 years. Exposure could cause severe radiation burns, the equivalent of exposure to 10 chest X-rays in an hour. The long-term effects could include cancer. The disappearance triggered a major search by WA State Fire and Emergency Service teams using radiation detectors. They were later joined by federal authorities using more sophisticated technology, which eventually detected the missing pellet just a few metres off the road, about 200 kilometres from the mine. Australia's Radiological Council will now investigate exactly how the capsule was lost in the first place. It should have been placed in a secured radioactive container, and in such a manner that it couldn't simply fall off the back of a truck. The outcome of that report will determine whether or not charges will be laid against Rio Tinto or any of its employees. Egyptologists have discovered a hidden 9-metre-long corridor near the main entrance of the Great Pyramid in Giza. A report in the journal Nature claims this discovery could contribute to knowledge about the construction of the Great Pyramid and the purpose of that gabled limestone structure which sits in front of the corridor. Standing some 146 metres tall, the Great Pyramid was constructed around 4,560 years ago as a monumental burial tomb for the pharaoh Khufu, also known as Cheops. Archaeologists believe the unfinished corridor was likely created to either redistribute the pyramid's weight around the main entrance, which is located around 7 metres away, or away from another as yet undiscovered chamber. Scientists discover the corridor by carrying out cosmic ray muon radiography scans and using a tiny endoscope camera fed through a joint in the pyramid's building blocks. It's similar to scans used to find a 30-metre-long void in the same pyramid back in 2017. A new study published in the journal Sleep Research has investigated the relationship between sleep disorders and a belief in the paranormal. The authors found poorer subjective sleep quality, including lower sleep efficiency, longer sleep latency, shorter sleep duration, and increased insomnia, all appeared to be associated with a greater endorsement of belief in supernatural things, like the soul living on after death, the existence of ghosts, demons, and ability of some people to communicate with the dead, near-death experiences being evidence of life after death, and aliens from other worlds having visited the Earth. Tim Mendham from Australian Skeptics says the belief in aliens was especially associated with episodes of so-called exploding head syndrome, as well as isolated sleep paralysis.
What it says is that basically people who suffer from particular sleep conditions, and they're talking about exploding head syndrome, which is basically when you're just about to fall asleep, you hear a bang, like a crack, like a rifle shot, and it sort of wakes you up. It's quite shocking. And also sleep paralysis, which is often when you're waking up and you can't move. And now, the statistics of this survey that was done in association with BBC publication had a high percentage of people suffering from these conditions. More than 50% of people would say they had experienced exploding head syndrome. It sounds more dramatic than it is. And a fair percentage have suffered from
very
sleep.
messy.
It does. I've had it. I've experienced it too, and it's quite scary at times, actually. And you think, what the hell was that? Is that someone in the house? Is that someone shooting someone out on the street? What is it? And it's just that moment.
Never had that. Had the falling thing. I get that a lot.
Yeah, the falling thing is pretty common. We just falling asleep, right, and go, well, you pull yourself up. That's pretty common too. But this does exist. And what they're saying is that people who suffer from these things also tend to have certain paranormal beliefs like life after death, alien abductions, the soul living on after death, ghosts, of course, and demons, and things like that. And they say that what is the reason that people who have these conditions have these beliefs? And the trouble is, as the survey writers admit, it can be the reverse as well. People who have beliefs in these things might have disturbed sleep, right, of any sort, not necessarily exploding heads or sleep paralysis. It could be a whole range of things. Now, the question is, are people who believe in paranormal things anxious, especially being taken away by aliens, which make you pretty anxious, or demons, or speaking to the dead, and therefore they have bad sleep? And that was one of the things they were looking at, not just exploding heads or sleep paralysis, but also poor sleep, disturbed sleep. So rather than saying people who have sleep problems believe in paranormal, it could be the reverse, that people who believe in the paranormal don't get to sleep well because they have all these anxieties. There's also the problem that this particular study was...
It's hard to sleep when you're worried about monsters under the bed.
Very much so, or being whisked away by a UFO or something, or a demon, or even talking to the dead people. Yes, it is. So I would suggest that it might more be that way than people having sleep problems believing in the paranormal. But there's an interesting correlation. One of the problems is with this study that they admit to is that it was a self-elected survey group. They basically advertised it through BBC Focus magazine and asked people who are suffering from these sleep conditions, sleep disturbances, about their sleep issues.
So we don't know exactly what percentage of the population really has it.
That's exactly right. And that might indicate that a high percentage of the respondents do have these disorders. Because as I said, the survey said over 50% of people have the exploding head syndrome, but that might be 50% of a particular bunch of people who are keen to actually write into a survey, because I say these problems.
Of people who did the survey.
That's right. So this study goes through and looks at the correlation between paranormal beliefs. It seems like they're asking about the sleep problems, and that is what got in the audience. And then they ask them all these other questions, including, do you believe in this, this, and this? The correlation there is very interesting. In some cases, it's a bit tenuous. In other cases, it seems quite close. But the interesting thing is that of the survey group, as biased and as self-selective as that is, more than half reject a lot of these ideas of, say, soul after death, in which case you're getting about 50% saying definitely not or don't think so, and then another quarter of the group saying not sure. So when you get down to the definitely yes, people believe in souls after death and ghosts and communication with the dead and aliens, etc., the actual number of believers goes down quite small, which is interesting compared to general surveys, which say that actually quite a lot of people believe in life after death and communicating with the dead, and certainly ghosts and psychics and things like that. Well, it all comes back
to, can you imagine a world without you? And it's hard for people to do that.
Yes, that's often the issue, that why people might go to see psychics and things, because it's a pretty depressing thought. The world without me, or the world without my family, my much-loved family. So this is an interesting survey with some caveats.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.